All right, the last one that I'm going to guide you through here today is Sketch 3 push button. And for this one, the main thing we really need to look at is sort of the configuration when we put in our button. So I'm opening that image and zooming in on it. It's not the best. So let's put that button in there. And the way that these things work, it really plays a factor into how we, well, obviously plays a factor in how we're going to adjust this. So let's just throw in some wires here. Let's make this one red because we connected it to power. Let's connect this one to ground. We'll make it black. So in this configuration right now, we would not complete this circuit here. It's broken until I press that button. When I press that button, it makes that connection. It is automatically making a connection. Come on, if I can draw from there to there. Let's make that black as well. So if we think about our button has like two states. We can either be pressing it down and it touches a plate, or we can not be pressing it and it touches the top plate. There's like sort of a top plate and the bottom plate. When you are not pressing the button, it's making contact with the top plate, and it is allowing, it is connecting these two terminals right here. So it's labeled, if I hover over it, come on, 2B and 2A, 1A and 1B. Those are connected together when you're not pressing the button. When you do press the button, it makes it like a U. So it goes from 2A to 1A, or from 1B to 2B. And it also like crisscrosses. It goes from 1A to 2B, or from 2A to 1B. So you need to understand that when you're not pressing it, it's going straight through. When you are pressing it, it's doing a U-turn or crossing. And that's critical to being able to use these buttons. So that's the first thing. I'm going to just use utilize the U-turn thing. Let's go into our code, and I have my code from the previous one, and let's take a look at what it's asking us to do and what it's asking us to do. So I'm not going to follow along exactly, but this is sort of telling us, start a program, save it as whatever. Define a constant integer named button pin and assign it to pin 12. Let me go back and look what I put that. Oh, I didn't put the button to anything. But I can take this one, I'm just going to move it down here. I'm going to make it 2. So I'm going from this side to the button. I'm going from power through and then over this side back to the button. I'm going to need some other things here in a minute, but let's go back to code. And so I've got this red LED called out right now. I don't need that one. So I'm going to call this one, just use the same name that it said, button pin, using that camel case, and I'm going to make it a 2. Coming down here, it says LED pin. I'm going to make this button pin, and I'm going to make that as an input because this is reading whether I'm pushing or not pushing that button. So if I want to read that button, instead of when I made the LED flash, I was giving it a 0 or a 1, and it was turning on or off. Now I'm going to take in some data. As I'm taking in that data, I'm going to do a digital read. Gotta spell digital right. Digital. Read again using that camel case, and I'm going to digital read on button pin. And if I just have just that, this highlighted portion returns a value of 0 or 1. But I need to do something with that 0 or 1. I need to be able to store that 0 or 1. I'm going to store it in a variable. So I need to declare a variable, and I do so with, well, the same way I have it declare that constant, except it's not constant, it's going to vary, so I just don't put the term constant in front of it. So int stands for integer. I'm going to name my integer just state, and I'm going to set it equal to 0. It doesn't really matter. I'm initializing it to 0 there to start. And then I can set, does that work? Yeah. I can set state equal to whatever I'm reading from that pin. So it's going out and looking at that pin. It's saying perform a digital read of button pin. We know that button pin is pin 2. So it's seeing, is it getting a signal on button 2 or on pin 2? And when it's not, it's storing a 0 here in state. When it is, it stores a 1. And then we're going to do something with that. So I could say if state equals, that's a comparator. We remember that, well, we should remember that from robot C. I used some open and close brackets to put whatever is going to happen when the state is 1. We know that we want to turn on the light, turn on the LED. So I'm going to take this one, that line right there, and just paste it inside that that portion. Otherwise, I'm also going to do some brackets. So otherwise, we want to turn off the LED. So I'm going to set digital write to be low. And I don't need any of the delays or anything. It should be just instant. And so here, it's going to, all this is doing is over and over again, it's going to read the button, see if it's being pressed, store that value, and then if it is being pressed, it sends a signal, a high signal to the other pin, and if it's not, it sends a low signal to that. And it does this over and over again, super fast, so it's got no lag. And this should work. This actually, let's go see what it does right now, because I've missed one thing, and it will be instructive to kind of see this. So let's hit start simulation. And it's taking a while. There we go. If I press the button, oh, it's just on all the time right now, which is interesting. So why is it getting a signal all the time? That is on. So let's show you what's happening here. If I throw a resistor on here, and I might need to move that. All right, we're going to need to move that.